Hello friends, we are discussing human excretory system. In our last video, we have learned some important concepts, and in this video, we are also talking and discussing some important aspects. So first of all, we are discussing PCT and its function. Two main functions of PCT is reabsorption of water and electrolytes and maintaining pH and ionic balance. PCT is doing its duty by secreting hydrogen ion, ammonia and potassium ion and by absorbing HCO3. And this is done effectively because of PCT is lined by cuboidal epithelium cells which increase surface area for reabsorption. So now coming towards Henle's loop. Ascending limb and descending limb plays significant role. The ascending limb is impermeable to water but allows transport of electrolytes actively or passively and therefore filtrate pass upward. While in descending limb, it is impermeable to electrolytes and permeable to water. Therefore, concentrate filtrate moves downwards. And now let's see the function of collecting duct. This is a long duct which starts from cortex of kidney and ends in inner parts of medulla. So large amount of water could be reabsorbed from this to maintain the osmolarity. So it also plays important role to maintain pH and ionic balance of blood by selective secretion of hydrogen ion and potassium ion. And now in DCT, what happens? This part is capable of conditional reabsorption and selective secretion. In this part, there is a conditional reabsorption of sodium ion, HCO3 minus ion and water. And also selective secretion of hydrogen ion, potassium ion and NH3 to maintain sodium, potassium and pH balance. And now coming towards collecting duct. It's a long tubule which starts from the cortex of the kidney to inner parts of the medulla. Large amount of water could be reabsorbed from this region to produce a concentrated urine, and this segment allows passage of small amounts of urea into medullary interstitium to keep up the osmolarity. And pH and ionic balance is also maintained by the selective secretion of H plus and K plus ion. And now one more important topic to understand the mechanism of concentration of filtrate means our urine is concentrated. Why? Due to Henle's loop and vasa recta. You know very well that Henle's loop has two limbs and the flow of the filtrate in these two limbs is in opposite direction. So it forms counter current, and flow of blood in vasa recta also is in opposite direction and hence it forms counter current. Now we know that Henle's loop and vasa recta are in proximity, so osmolarity is maintained 300 mole per liter in cortex and 1200 mole per liter in inner medulla. So this gradient is caused by NaCl and urea. NaCl is transported by ascending limb of Henle's loop and then it is exchanged with the descending limb of vasa recta. And similarly, small amount of urea enters the thin segment of ascending limb of Henle's loop, which is transported back to the interstitium by collecting tubule. And all this process is called counter current mechanism, and this mechanism helps to maintain concentration gradient. Due to this gradient, there is an easy passage of water and concentrated filtrate is formed, means urine is formed. And now let's know how kidney function is regulated. It is regulated by hormonal feedback mechanism with the involvement of hypothalamus, JGA and heart. If there is any change in blood volume or body fluid, what happens? That there is an activation of receptors and hypothalamus is activated and ADH or vasopressin is released from neurohypophysis. And because of ADH, there is a water reabsorption and hence there is a prevention of diuresis. And if there is an increase in body fluid, there is no need to ADH release, so osmoreceptors will be switched off. And one more thing, ADH helps kidney by its effect on blood vessels. Due to this effect, there is an increase in blood pressure, and blood pressure is increased, glomerular blood flow is also increased, and hence there is an increase in GF. So now coming towards the role of JGA. It plays complex role. If there is a fall in GBF, GBP or GFR, JG cells gets activated and release renin. And what is the function of renin? It converts angiotensinogen in blood to angiotensin 1. And from angiotensin 1, it is converted to angiotensin 2. And angiotensin 2 is a powerful vasoconstrictor. So it increases GBP and GFR. Angiotensin 2 is also activates the adrenal cortex to release aldosterone, and aldosterone helps in reabsorption of sodium ion and water from distant part of the tubule, and due to which GBP and GFR is increased, and this mechanism is called renin-angiotensin mechanism. And now if blood flow is increased, then there is a release of ANF, atrial natriuretic factor, and due to ANF there is a dilation of vessels, means vasodilation, and therefore there is a decrease in blood pressure. So you have to remember two mechanisms, renin-angiotensin and ANF. This both mechanism regulates the function of kidney. So now let's try to understand the micturition. Micturition means process of releasing urine. When urinary bladder is filled with urine, stretch receptors on the wall of bladder send signal to CNS, central nervous system. CNS passes motor message, and hence smooth muscles of bladder gets contracted and urethral sphincter is relaxed, and hence there is a release of urine. An adult human excretes on an average 1 to 1.5 liter urine per day. Color is yellow, pH is slightly acidic 6.0, and on an average 25 to 30 milligram urea is excreted per day. Due to various body conditions, there is a change in characteristic of urine, so it helps in diagnosis of various conditions like kidney failure, diabetes and some other diseases. Say for example, presence of glucose or ketone in urine indicates diabetes. And other than kidney, there are other organs like skin and liver also helps in excretion. Large amount of CO2 and some amount of water is removed by lungs. And one more interesting thing, that liver is the largest gland in our body which secretes bilirubin, biliverdin, cholesterol, degraded steroid hormones, vitamins and drugs. And most of the substance pass out with digestive waste. And skin also helps in excretion through sweat glands and other sebaceous glands. Sweat gland removes unwanted substance like urea, lactic acid and NaCl through sweat. And sweat gland also provides facility of cooling effect. Sterol hydrocarbons and waxes are removed by sebaceous gland through sebum, and due to that we get protective oily covering to skin. And you must know that some amount of nitrogenous waste is also removed through saliva. And now coming towards the disorder of excretory system. One, glomerulonephritis means inflammation on the glomeruli of kidney. And number 2 is renal calculi. In general, we call it kidney stone. They are insoluble mass of crystallized salts called oxalates. Next is malfunctioning of kidney. Kidneys malfunctioning means accumulation of urea in blood, which is removed through a process called hemodialysis. In hemodialysis, there is a journey of blood from artery to vein through dialysing unit. So blood is taken out from artery and then pumped into dialysing unit after adding anticoagulant substance like heparin. In dialysing unit, fluid is same as plasma except nitrogenous waste, which allows the passage of molecules according to concentration gradient, and nitrogenous waste is absent, so dialysing fluid clears the blood and then it is pumped back through vein after adding antiheparin substance. In case of acute renal failure, kidney transplant is the ultimate method, and for that donor kidney is needed, and preferably it should be of close relative, so it is not rejected by patient's body because of its immune system. It's a very complicated procedure, but nowadays due to latest technology, success rate is very high. And so friend, that's all for this video. Thank you for watching my video. If you like it, please share and subscribe my channel. Thank you.